again, wonderful Las Colinas science students. So now I have in front of me a piece of steel wool, and this is going to act like our conductor, our wires. This is really thin, really thin pieces of steel, and that's going to act like a wire to conduct electricity. And for this one, I'm going to use a 9-volt battery. And both the positive and the negative are on the top of the 9-volt, and you can see it has a positive sign right there, so that means this one is the negative. And both of these nodes need to be touching the steel wool. So we've been talking about safety devices in your notes. It talks about circuit breakers and fuses. So what you do for this lab is, again, this is really finely spun, it's like thinner than hair. Steel wool that will act like wires. So I touch the 2 nodes to the steel wool, and then the power will run through it. And it's acting much the way a fuse would. It's burning through this. The electricity is running through the metal, but it's kind of changing color. We'll zoom in at the end so that you can see that. But it's acting like a fuse and kind of melting it as the electricity is surging through the little metal wires there. Ooh, that was a good one. And once it is burned out, it will not burn again. So this is a safety device acting much like, again, like a fuse does. Fuses have little thin pieces of metal in them. So when the circuit is too high, where there's too much power going through them, they will melt, and then you'd have to change the fuse. So we'll see if we can zoom in on the color change, where this is where it was burned and melted, and you can see the difference in color right here. This one is still silvery, but this almost has turned like a bluish black, and that's what a fuse does too. It melts, so it prevents the device from overheating and catching on fire. So thanks guys, see you next time.